Hello, welcome to this first lesson, which is installing Unreal Engine 4. We're going to be covering creating an Epic Games account on unrealengine.com and then downloading and installing the Epic Games launcher, which will allow us to download and install Unreal Engine version 4.20. So to get started with downloading Unreal Engine 4, you will first need to open up your web browser and come to unrealengine.com. On this main page, up in the top right corner, you'll see a big blue download button. Go ahead and click this button, and for the first time, if you don't have an account, it will bring you to the Epic Games account creation page. Go ahead and sign up for an account, and then it will bring you to this download page. On this page, it says you must agree to the appropriate end user license agreement. Basically, when you click this proceed to download button, it basically means that you automatically enter and agree to the end user license agreement that you can view on this link here. Once you've done that, we can proceed to the download, and this page will ask us which platform we want to download for, so either Windows or Mac. So go ahead and download and install the Epic Games Launcher for the platform you are currently running. So I'm going to assume you've downloaded and installed the Epic Games Launcher now. So go ahead and launch it and log in with your Epic Games account. The first time you do this, you might be in the home section of the launcher. Now we want to be in the Unreal Engine section, and we can do this just by clicking on the Unreal Engine button down the side here. So this brings us to the Unreal Engine section. Now we want to download and install Unreal Engine 4. So where do we go to do this? Well, on the top bar, we have these different category tabs, and one of them is the Library tab. So let's go to the Library tab. The Library tab is where we can download and install different versions of Unreal Engine 4, and it's also where we can browse and launch the Unreal Engine 4 projects we have on our machines. Now there's different versions of the engine we can install, and throughout the duration of the course we're going to be sticking with just one engine version for consistency. The version we're going to be using is Unreal Engine 4.20, and you can see that I already have 4.20 installed on my machine. You can see it shows 4.20.3. So Epic Games will patch particular versions of the engine if any bugs are discovered in them. It's possible that it might be 0.4 or 0.5 by the time you take this course, but I wouldn't worry about this. Just focus on the main version number here, which is going to be 4.20. So 4.20 is what I want you to download and install. To add an engine version, click this gold yellow plus icon just next to where it says engine versions, and it will add an engine installation for us. Before we hit install, we first must choose an engine version. We can just drop down the version number here and we can choose 4.20. Now I already have 4.20 downloaded and installed, so I can't select it here. So just double check that you select 4.20. And once you've done that, we can hit install. We're now prompted to choose an install location for the engine, and it suggests one for us, but if you're not happy with this, you can click the browse button and browse to any directory on your machine where you want the engine to be installed to. So before we hit install, let's just click the options button because I want to show you something. The option button shows you everything that's been downloaded and installed with the engine, and if we scroll down, we can see this target platforms section here. Now, if we're never going to develop on any of these platforms, we can actually uncheck all of these, and this will greatly reduce the download size of the engine. Okay, we can just hit apply, and now we can hit install to start downloading Unreal Engine 4.20. Hey, welcome back. In this lesson, we're going to be taking our first steps in Unreal Engine 4. We're going to begin by creating our first blueprint project for the game Marble Run, and then we'll move on to learn how to navigate Unreal Engine 4. To do this, we're going to start breaking down the editor's interface, and we're also going to take a look at what makes up a level. So we now have Unreal Engine 4.20 downloaded and installed. To launch the engine, we can simply hit the launch button on our engine installation. We can minimize the launcher after we've done this, and we should see a splash screen showing the progress of the launch. If it's your first time launching the engine, it won't do this instantly, so we just have to be patient with it. And once launched, we are brought to the Unreal Project browser. Again, here we can browse the projects that we currently have on our machine, but we can also create Unreal projects by switching over to the New Project tab. And this is what we want to do. We want to create a new Unreal project. Now it tells us to choose a template to use as a starting point for your new project. So there's different starting points for us. We can choose between Blueprint or C++ projects. Of course, this is a Blueprint course, so we're going to stay on Blueprint, and there's different templates we can choose here, but we're not going to use a template. Instead, we're going to start with a completely blank project. So we want to make sure we're on the Blueprint tab and that we have blank selected. And now we can move on to adjusting some settings for our project. And it does say, don't worry, you can change these later in the target hardware section of your project settings. So what we can do here can actually be changed at any time. But to start, we can choose a target platform. We can choose between mobile or tablet or desktop and console. We're developing for desktop here, not mobile, so I'm going to leave this as it is. We can change the quality of our target platform, basically the graphics. I'm going to leave mine at maximum quality. And finally, we can choose if we want to include starter content. Now we actually do want to include the starter content because this adds lots of materials and objects that we can work with to start building games with. So make sure to include the starter content. Next, we can move on to choosing a location on our machine for the project to be stored. I'm happy with the suggested location here, but to change it, you can click these three dots to browse your machine to a directory where you would like your project to be stored. And finally, we can name the project. So I want to name my project Marble Run. But notice when we do this, we get an error. It says project names may not contain a space. So we're going to start seeing this a lot as we create a name assets in Unreal. We want to use a camel case naming convention, meaning multiple words are joined without spaces with each word capitalized. So really what we want to do is name this Marble Run without any spaces there. And now we can just go ahead and hit create project, and this will launch the Unreal Engine 4 editor for our project. Okay, so here we go. This is our first real look at the Unreal Engine 4 editor, and we're going to begin by breaking down the editor's interface. Straight away we see there's lots of different things going on. We see these chairs and table in the center window. On the top bar we see all these different buttons, and on the outskirts of the editor we see these different individual tabs that make up the editor's interface. When we pan our mouse around the editor's interface, we begin to see different areas highlighting. This means that we can click and drag and we can resize the interface to our own liking. Okay, so we're beginning to see customization already with the editor. With the different tabs that are open, we can do this on any tab. We can click and drag on it and we can undock the tab and place it on our screen and move it about to anywhere we want. But we can also dock them back onto the editor's interface in a different location. Okay, so now we're really starting to see customization of the layout of the editor. What happens if we accidentally close one of these tabs? So if I close this Modes tab, how do I bring that back? Well, if we come up to Window, which is just next to File and Edit, we can click this and we can restore different tabs here. So I'm going to restore the Modes tab now. And now it restores it back to its original location. We can even undock this and redock this onto existing tabs as well, and we can tab them together. I'm just going to go ahead now and close all these tabs, and so we can just focus in on this center window where we have these chairs and a table. This window is the viewport. It's showing us the game world. It's showing us the current level that is open, and we can see this down in the bottom right corner of the viewport. It says we're in a level that is named Minimal Default. Okay, but what is a level? Well, really, at the foundation, a level or a world is just a collection of different individual actors. And we can see this further by restoring the world outliner. If we come up to Window and then World Outliner, we can see that the world outliner shows us a complete list of all the different individual actors that make up our level. And it says here that we have 15 total actors. Okay, we can see that we have some chairs, a floor, statue and table, and these are static mesh actors. If we just move this over to the side, it says that the type of actor is a static mesh actor. So we're going to begin to see that there's lots of different actors inside Unreal Engine 4 as we move throughout this course. We can hide actors and toggle the visibility of them by clicking and closing this eye and clicking it again to toggle the visibility of them. Okay, so we've taken a look at the world outliner and actors that exist in our level. But what is this minimal default level? Where did it come from? Well, if you remember back, we added in some starter content, and we can view the starter content by coming to the content browser. If we come to Window and Content Browser, we can restore the content browser by hitting content browser number 1. Okay, if we restore content browser number 2, that just adds a new instance of the content browser that we can place anywhere on our screen. So that doesn't really mean anything. It just opens a new instance of the content browser. Well, we have the starter content in here. If we double click this folder, it shows us more content, and we can double click the maps folder and it shows us this is where the minimal default level is. If we double click this, it's just going to restore the same level because this is the current one that we already have open. So we've taken a look at how we can customize the layout of the editor's interface. So right now there is something I want you to do. I want you to change the interface, have a go at redocking tabs in different locations, and then let's move on to creating a minimal interface. To do this, I want you to close all the tabs so we just have the viewport left. Okay, so pause the video here and have a go at that, and then when you're ready, just hit resume. Okay, so well done. I wanted you to get some hands-on experience with the editor's interface. So I asked you to redock tabs in different locations. To do this, we can just click and drag the tab and we can release it on different areas of the interface. We can also dock them together with other tabs and we can toggle between them. I then asked you to go ahead and close all the tabs so we just have this minimal interface look showing us only the viewport. In the next lesson, we're going to learn how we can navigate the viewport and how we can begin to edit actors that exist in our levels. Hey, welcome back. This lesson is Viewport Navigation and Transforms. In this lesson, we will learn how to navigate the viewport. And then we will start learning about actors within the viewport. We will learn how to edit the location, rotation and scale of an actor, and we will learn about Unreal units, and we will also learn how to duplicate an actor. And then we will finish off this lesson by creating and saving a new level. So in the previous lesson, we reduced our editor layout to this minimal interface look where we just see the viewport. So now let's take a look at how we can navigate around our level from inside the viewport. If we look down towards the bottom left corner, we will see this question mark, and when we hover over it, it says click to show viewport controls. So if we click here, it's just going to bring up a web page that gives us a complete list of the controls that we can use to navigate the viewport. So you can pause here and take a quick look at the controls, but I'm just going to give us a quick rundown right now of the controls. If we close out of this, if we hold down the left mouse button in the viewport and pan the mouse forwards and backwards, we will move throughout the world. If we pan the mouse left and right, we will turn on the spot. If we hold down the left mouse button and the right mouse button at the same time and pan the mouse forwards and backwards, we will move up and down throughout the world. If we pan it left and right, we will strafe left and right throughout the world. If we just hold the right mouse button by itself and pan the mouse, we will pan the camera around our level. Okay, so that's one way that we can navigate around. What's a different way? Well, if we hold the right mouse button down and press W, we will move forwards. If we hold S, we will move backwards. If we press A, we'll strafe left, and if we press D, we will strafe right. If we press Q, we will move down, and if we press E, we will move up. And when we move, we can probably see that we're moving quite quickly. If we scroll down on the mouse wheel and keep scrolling down, our movement speed will eventually change and we will start slowing down. And if we scroll up, you've got it, we can start speeding up. So we have complete control over our movement speed by using and scrolling the mouse wheel. We can also adjust the camera speed by looking up towards the top right of the viewport, and we have this camera speed. We can just click this and adjust this slider to control the speed. So I don't expect you to remember every single control that we have just covered. However, I would encourage you to take a moment and pause the video here. Make sure to check out the viewport control list and then just have a go at navigating around the level within the viewport. And when you feel comfortable, come back to the lesson and just hit resume. So I hope you're feeling somewhat comfortable with the navigation now, but really the more you navigate in the viewport, the more you will get used to it. So let's move on and take a look at what we can do with actors inside the viewport. We can select actors just by left clicking on them, and when we do this we see this little gizmo here. This is the translate tool, and it allows us to move an actor in our level. We can do this just by clicking and dragging on one of these arrows here, and when we do this we are constraining and translating the actor across a particular plane of movement. So for example, with the red arrow I am translating this actor across the X plane of movement. With the green arrow I am translating the actor across the Y plane, and with the blue arrow I am translating the actor up and down on the Z plane of movement. In some other game engines Y is up, but in Unreal Z is up. And we can translate across multiple planes at a time by clicking and selecting these bars here, and when we do this we are translating across 2 planes at a time, and we can translate across all the planes just by clicking and dragging on this center here. So when we move an actor, really we are affecting this actor's transform, and we have different transform tools. So this translate tool is one of the transform tools. If you press E, we can switch to the rotation tool, and we can rotate the actor on the yaw, pitch, and also on the roll here. We can press R to scale the actor uniformly or non-uniformly. Okay, we can press W to switch back to the translate tool, and when changing tools we see in the top right of the viewport these icons changing, showing us which tool is active. And we can also toggle between these tools just by clicking on the icons. So the location, rotation and scale of an actor makes up the actor's transform. Let's just bring back the details panel quickly. If we come up to window and then details number 1, we can see we have this transform section when we have the actor selected, and this is giving us the world location, world rotation and world scale of the actor. Okay, we can see X, Y and Z here as well. When we hover over in the rotation it's showing us the roll, pitch and yaw. We can see that when we translate an actor, the coordinates of the actor's world location updates. The same applies when we scale an actor, and the same applies when we rotate an actor. So when we use these tools we are changing the transform of an actor. We can also change an actor's transform directly within the details panel. We can click and type it in values for the X, Y and Z here, and even on the rotation we can click and drag the yaw, pitch or roll to rotate the actor. So to summarize, each actor has a transform. When we select an actor, in the details panel we see a breakdown of the actor's transform, and we can see that a transform is made up out of location, rotation and scale. In the viewport we can edit an actor's transform by using the transform tools. So let's move on and take a look at Unreal units. With this chair selected we can see we have an X value of 5 for its location. This is 5 Unreal units. If I change this to 6, I've just moved it forward by 1 Unreal unit. And 1 Unreal unit is equal to 1 centimeter. So I've just moved it by 1 centimeter. But what happens if I just translate the actor using the translate tool? Well, if I just nudge it forwards once, we can see that it's now increased by 10 centimeters or 10 Unreal units. So why did it do that? Well, we can see we've got this huge grid that covers this whole level, and currently we are snapping to the grid when we translate this actor, and we can see this further by looking up towards the top right of the viewport. We see it says enable or disable snapping to the grid with this icon, and it's got a value of 10, so we're snapping by 10 Unreal units. If we change this to 100, we can see that the grid changes, and now we are snapping by 1 meter. Okay, so that's translation snapping, but we can also snap with rotation. We're currently snapping at an angle of 10 degrees, but we can change this to different angles, such as 30 degrees here. And we also have snapping for scaling, so it's at 0.25. We can also change this so we have different incremental sizes of scaling. I'm just going to zoom out right now and I'm going to show you how we can duplicate actors. If we select this floor piece and if we hold down left alt and translate the actor, we will duplicate the actor. Okay, so that's one way we can duplicate it. We can also switch to rotation mode and we can duplicate it by holding left alt and dragging as well. But how do we undo any changes we make? What happens if we make a mistake? Well, we can undo. If we come up to Edit up in the top left of the editor next to File, we can do Edit, Undo, or we can press Control and Z, and this will undo our changes. And if we made a huge mistake, we can always just reopen the level by either bringing back the content browser and opening the minimal default level, or we can come up to File and then Recent Levels, and we can come to the most recent level, which is of course minimal default. And we just want to hit Don't Save because we don't want to save any of these changes. And now we have the minimal default level back to its original state. So we now know how to edit the transforms of actors and even duplicate them. So right now let's put these new skills to test with a fun little challenge I have for you. So word is getting around about your new Unreal skills, and tonight we've been asked to host a dinner party inside the minimal default level. Tonight we have to set 3 tables, and we need to be organised, so each table needs to be on its own floor. Each table needs to be decorated with its own statue, and the guests arriving tonight have unique requests for their tables. Table 1 is bringing 5 guests, and they've requested their tables and chairs to be scaled by 0.5. Table 2 is bringing 3 guests, and they have requested their tables and chairs to be scaled by 0.835. And Table 3 is just a single guest who requests their table and chair to be scaled by 1.6. So remember to pause the video here, take a look at this slide including the image I've added on the right, and just make use of what you've learned so far in this lesson. And if you make a mistake, don't worry, you can always press Ctrl Z to undo, or you can reset the level by reopening it. So good luck, and I'll see you in a second. Okay, so let's take a look at how we can do this. I'm going to start by zooming out. I'm going to select my floor piece and change my snapping size to 100 Unreal units. We can hold left Alt and drag on the translate tool to duplicate. So we can duplicate a floor piece and duplicate the table. So now we have 3 tables and 3 floor pieces. We can select the statues and duplicate them to decorate the tables. And we can move one of the chairs over to a table, and we can duplicate another chair to another table. Okay, so this is looking good. Let's move in closer to one of the tables. So let's say this is table 1. It needed to be scaled down by 0.5. So we can switch to the scale tool to do this, and we can see the scale in the details panel. We can also use the scale tool to scale the chair down to 0.5, and I'm going to move it closer to the table. We can change the snapping size just to get a better position for the chair here. Now for the statue, we can bring that down, but we might need to change the snapping size to a lower value to make it fit onto the table. We can select chairs and rotate them so they can rotate inwards towards the table. And we can just go ahead and duplicate them so we have 5 chairs. For the rest of the chairs here, I'm just going to fast forward the video. And remember, we can use the angle snapping as well, just to snap the chairs in a better position. And don't forget, you can manually type in an actor's transform from within the details panel. And remember to turn off snapping by hitting the icon on the viewport, which will allow you to have some freeform placement. Okay, so I hope you took the time to try this challenge, as it would give you some hands-on experience with navigating in the viewport and editing actor transforms. Now, let's wrap up this lesson by creating a new level ready for the next lesson. To do this, we can come up to File and then New Level, and it will ask us to choose a template as a starting point for our new level. Let's just go ahead and choose the default. Do we want to save changes to minimal default? Sure, we can just hit Save Selected. Okay, and now we have a new level. Let's save this level straight away. We can come up to File and Save Current, or we can hit Save Current on the toolbar. So let's click this. It's going to ask us to name our level. I'm just going to name mine Level 1, and we can hit Save. And if we bring back the content browser, we can find our level in the main directory under a folder named Maps. So if we go inside this folder, we have a level 1 now. Okay, so this is the end of this lesson, and in the next lesson, we're going to start building our game Marble Run by having our first introductions to blueprints. So when you're ready, I'll see you in the next lesson. Hello and welcome back. So things are moving forwards now. This lesson is Blueprint Introduction. We're going to start by seeing what happens when we press play to play our game. And then we're going to move on and have our first look at blueprints. We're going to start by working inside the level blueprint. We're going to learn how to execute code, and then we're going to take a look at how we can print messages to the screen. Okay, so let's take a look at this play button on the top toolbar. When we click this, we are going to play our game. Let's give it a try. Okay, so it doesn't really look like much has happened, but that's to be expected because we don't really have a game yet. But something has happened. We can see that our camera has moved to the center of the floor. We can focus the viewport by left clicking into it once. And with the viewport focused, we can pan our mouse around and look, we're moving the camera without even pressing any keys or buttons down. We can move around with W, A, S, and D, and we've got some sort of presence in the world now. We can move to this floor, and the floor will stop us from actually moving through it. So there's a specific reason for all of this. This is because we are now playing the game as Unreal's default pawn. A pawn is an actor that can be possessed and controlled by a player. Let's break this down a little further. I'm going to stop playing the game by hitting escape. And now I'm going to bring back the world outliner. If we come up to window and then world outliner, we can see that we have 7 actors in our level. But look, if we hit play, we suddenly have 18 actors. And check it out, the default pawn is one of them. I'm just going to stop the game again by hitting stop. So what's really going on here? Well, we can see that we have this icon in our level with this arrow on it here. This is the player start. We can select it and we can move it around. Okay, and when we actually hit play, Unreal is spawning the default pawn at the player start, and then we possess the default pawn and we can control and play as it. So check it out. Look, if we hit play, we have now spawned at the player start, but look, if we press Shift F1, we can bring the mouse back and we can hit eject. Okay, and look, it says possess. So we've just stopped possessing the default pawn. We can zoom out a bit with the usual editor controls because we're back in the editor mode now, and look, we can see the default pawn. It's basically just a floating invisible sphere. So when we press play, Unreal finds our player start in the level and it spawns the default pawn at the location of the player start. And then we possess the default pawn, allowing us to play and control it. So now we know how to play our game. Let's move on and begin our journey with Blueprints. Blueprints is a very powerful visual coding system built directly into Unreal Engine 4. And we're going to start by coding inside the level blueprint. To find the level blueprint, we can come up to Blueprints on the toolbar, and when we click this, we can open the level blueprint here. Okay, so this is our first look at blueprints, and just like with our first look at the Unreal Engine 4 editor, we can close all these surrounding tabs, and I'm going to do this now just so we can focus in on this center graph. So Blueprints is a node-based visual coding system, and we can see 2 nodes on the graph already. One is event begin play and one is event tick. So there's this comment on begin play and it says this node is disabled and will not be called. Drag off pins to build functionality. So let's try that. Let's start by printing a simple message to the screen when we start the game. We see this white arrow on the node. This is the execution pin. When we click and drag out from this pin and release it, it will open up a window where we can select an executable action. So to print a message to the screen, we want to look for a function named printString. We can find this by coming down to the utilities category, and we can double click on this to expand it, and we can expand the string section, and we can call this printString function. And look, this is what this F stands for. It is a function. So when we call this function, we can see that our nodes are now connected together in the execution pins here. Okay, it's telling us that when begin play executes, it will move on and execute this print string function. So let's take a look at what happens now. Let's close out of this blueprint and let's hit play. And look here, we just have a simple message that pops on our screen for a second and says hello. Let's head over back to the level blueprint. And look, we can expand this print string just by clicking this arrow here, and we can choose some more options here. We can choose the text color, so we can change the color if we want to. And we can also choose the duration of how long it is on the screen for. I'm just going to change mine to 10 seconds. And just like with regular coding languages and IDEs, we can compile our code just by hitting this compile button. But at this stage, we don't really need to compile our code because Unreal automatically compiles it whenever we hit play. So let's close out of the level blueprint now and let's see what happens. If we hit play, we now see this orange hello and it stays on our screen for 10 seconds. We can hit stop again and let's come back into the level blueprint. To stop the begin play from executing the print string, we can right click on any of these execution pins and we can hit break link, and look, it says break link to the print string. Okay, so now we have no execution flow going between these. We can also break the link just by holding down left alt and left clicking on one of these pins. So that's another way we can do that. We can move nodes just by selecting them and just moving them around as well. Let's take a look at executing our code a different way. We can affect how we execute our code. We can use some flow control nodes. If we drag out from the execution pin on begin play and come down to utilities, and then we have this flow control section. Let's expand this. There's a lot of different nodes here, but let's focus in on this delay function. This is pretty simple. We can delay our code by a certain duration of time. So if we just change this to 2 seconds, and then on the completed, after the delay has finished, we can connect this up to the print string. If we close out of the blueprint and hit play, it will now delay by 2 seconds and then show our message. So right now I have a challenge for you. Using what we've learnt, on begin play, I want you to print a series of messages to the screen. These messages can be anything you want, and you can call as many print strings as you want, and think about using the delay here as well. So good luck, pause the video here, and in a second I will run through the process with you. Okay, so there's no real order we need to do this in. I'm just going to drag out the execution pin from begin play, and I'm going to call the delay function. If we know the name of a function, we can actually type and search for it in this bar. And when we do this, Unreal is going to try and auto-suggest the closest result for us. Okay, so I can call a delay that way. I'm going to delay it by 3 seconds, and then I'm going to call a print string. And when we call a function, we can also see the category is under there as well. So print string, I'm going to print a message. What should we print? Let's print hello world in capitals, and I'm going to change the color of the text to something different. Let's change it to green, and we could put it on a duration of 5 seconds. I'm going to delay it again because we're going to create a series of messages here, and we can delay it by 2 seconds and then call another print string, and we can print another message such as blueprints are awesome, and we can change the color again to, let's change it to purpley pink here, and then we can change the duration to, let's say, 5 seconds as well. Okay, we can keep going with this, just keep adding as many as we want, but I'm going to finish it up here, and we can just hit compile and save here to save the level, and we can close it out and we can hit play. Okay, delay it by 3 seconds, hello world, delay it by 2, blueprints are awesome. Cool. Okay, so in the next lesson, we are going to be taking a deeper look into blueprints and start creating some gameplay events for the game Marble Run. So this lesson is referencing actors in blueprints. We're going to be making progress with the gameplay for Marble Run, and the idea for this game is that we have a maze and a ball, and the objective is to make the ball escape the maze by tilting it in different directions. So in our journey to make this happen, we'll be taking a look at how to reference actors in blueprints from our level, and how we can affect those actors at runtime with player input action events. So in the previous lesson, we took a look at this event begin play node, and we also have this event tick here, but we're not going to do anything with the tick right now. We're going to select it, and we're just going to hit the delete key on our keyboard to remove it from our blueprint. We're going to take a look at how we can call different events in blueprints. We can call events that react to player inputs, such as when we press a key on our keyboard. These are known as input action events. So how do we find these events? Well, we don't need to drag off from any nodes like we were doing before. We can right click anywhere in the blueprint on the graph and it'll bring up the menu and it shows us all actions for this blueprint. If we scroll down, we can come to the inputs category. When we double click here, it's going to show us more categories for input events. And look, we have keyboard events. When we double click here, it shows us a complete list of all the keys on a keyboard. I'm going to go ahead and just call the W key. And look, it's added this input action event for W to our blueprint. And we have two outputs. We have pressed and release. So when we press W, pretty simple, this node will fire here. When we release W, this one will fire. But what happens currently in the game when we press W? Well, we move forwards as the default pawn. I'm just going to print a simple string when we move forwards, and we can just print the message move forwards. Let's take a look at what happens now when we do this. But before I do that, actually, I'm going to break the link on the begin play so we don't have a bunch of print string messages. We just want to focus on this move forwards. So I'm going to close out the level blueprint and hit play. I'm going to focus the viewport by left clicking in it, and when I press W, we get our print string message, and it comes up every time we press W. But when I hold W, we're not actually moving forwards with the default pawn. Look, it stopped our movement. We can still move left and right and backwards, but we don't have our movement with the W key. So let's take a look at why this is happening. Let's come back to the level blueprint. And we want to bring back the details panel. We can come up to window and then details. And we can select this W node, and look in the top right on the details panel, it's showing us that we consume this input, and it says prevents actors with lower priority from handling this input. So obviously when we press W, we are moving forwards with the default pawn, but this W input action event is consuming the input, which stops the input from going to the default pawn. If we uncheck this, we can close the blueprint and hit play, and look, we can move forwards and we can still get our print string message. Okay, I just wanted to show you why that was happening. But I'm actually going to come back to the level blueprint, and we want to make sure we do consume this W key input, because we're going to use this to affect our floor actor. Let's come back to the editor. And as we can see, we have this floor in our level. Let's take a look at how we can use blueprints to affect the floor's transform. So let's select the floor actor, and in the details panel, let's look at the transform section. We have the location, rotation, and scale here, but we also have this mobility section. We can see that the floor is currently marked as static. So because of this, it's going to prevent us from editing the actor's transform dynamically during runtime or during gameplay. So we need to mark it as movable to allow this functionality. Okay, so now that we've done this, let's come back to the level blueprint. And because we have our floor actor selected in the level, look what happens when we right click in the graph now. Look, we can create a reference to the floor. Okay, this adds this node named floor here, and it shows us a blue pin. In Unreal or in Blueprints, when you hover your mouse over these pins, it will tell us the type of data that we are dealing with. So we are dealing with a static mesh actor object reference. So it's a bit of a mouthful, but basically we're dealing with a static mesh actor. In this case, it's our floor. So what happens when we drag out this pin? Well, when we drag out and release, we can call actions that make sense in context of a static mesh actor. We want to take a look at doing some rotation with this actor. So in our game, we're going to have a maze and a ball, and we want to affect the balance of the maze so we can try and make the ball escape. So how can we get started with that? Well, we want to start affecting the floor's transform when we send some input to the game. And remember, we took a look at what a transform is. It contains the actor's location, rotation, and scale. If we come down to the utility section, look, we have this transformation section here. If we double click on this, it's going to show us a bunch of functions that deal with transform. Okay, we're going to look for the add actor world rotation function. So this function is going to allow us to rotate our floor piece. And look, we have these delta rotation values here. We have roll, and we have pitch, and we have yaw. So nothing's going to happen by default because these are at 0, but we can change these values to change the rotation of our actor. But in order for us to make that happen, we're going to connect this function to some input action events. We're going to make it so when we press D, we're going to roll the floor piece right, and when we press A, we're going to roll the floor piece left. Let's break the print string on this W key here, and we can just delete the print string. With this W key, we can duplicate it by selecting it and hitting Control and W. And this gives us 2 W keys, which isn't really helpful, but look, on the details panel, we can change the input key. So we can come to keyboard and we can change it to the D key. Let's connect the pressed output to the add actor world rotation. And with our floor reference, there's not actually a limit on how many functions we can call from this single pin. So let's call another add actor world rotation function. And then let's duplicate the D key. And with this D key, let's go ahead and change it to the A key. And we just want to make sure we connect the pressed output to this function. So look, we now have the ability to rotate the floor actor with the D key and also with the A key. So when we press the D key, let's make it rotate the floor actor by 5 units on the roll, which is the X here. So we can just type in 5. And then with the A key event, let's change it to roll the opposite direction by changing the X value here to -5. So now we've set up the functionality, so when we press D, we will roll the floor actor right, and when we press A, we will roll the floor actor left. Okay, so let's come back to the editor by closing the level blueprint. Before we hit play, let's select the player start, and let's move it so we have a better view of the floor actor. And we can even rotate the player start, which will affect the orientation of the default pawn when we hit play. So let's go ahead and hit play now. And now we can rotate the floor with the A key and also with the D key. Awesome, so we've done all of this by coding inside of blueprints. So let's break this down. We have an event. In our case, we have the D key. When we press the D key, we execute our code. So we can consider that the event causes when and how our code executes. We then have a function. We have just used the add actor world rotation function, and we can consider this what happens when our code executes. Then we have the actor reference. We have our floor actor reference, and we use this reference to decide who is being affected by our rotation function. So I now have a challenge for you. We've taken a look at how to roll the floor actor, and using what we've learnt, I want you to make it so when we press W, we will pitch the floor actor forwards, and then when we press S, we will pitch the floor actor backwards. So pause the video here, give it a go, and in a second I will walk you through the process. Okay, so to do this, I'm going to take my W input action event and I'm going to move it to the right of these other two. We're going to create a kind of square with these functions and events here. So with the W, we want to add rotation to the floor. So we want to make sure we select the floor in the level, and then we can right click and create a reference to the floor. We can have multiple references in the blueprint if we want to reuse it somewhere else. And we can drag out from here, and we want to affect the floor's transform. Specifically, we're going to rotate it, so we can come down to Utilities, Transformation, and then Add Actor World Rotation. Okay, we're going to hook it up to when we press W, we are going to increase the pitch by 5 units. And then we can set up the S key, so we can right click and come down to Input, and then Keyboard Events, and then we can find S just down here. And then with the S key here, we can use the same reference and call the Add Actor World Rotation and hook this up to the pressed event. And we want to use -5 now. We can close the blueprint and hit play. So we can roll it left and right, and we can pitch it forwards or backwards with W, and then pitch it forwards with S. So we can invert those values just by flipping them inside the blueprint here. So we can change this to -5 and then this to 5. And now when we come back to the editor and hit play, we can roll as expected, and we can also pitch the floor actor as expected. Okay, so in the next lesson, we're going to be having some fun by adding a physics ball to our level and seeing how that reacts to our floor. So when you're ready, I'll see you in the next lesson. Hey, welcome back to this lesson, which is applying physics to static meshes. In this lesson, we're going to add the ball to our level. To do this, we need to know how to add content to our level from the content browser. We're then going to apply physics to the ball, which will give us this gameplay scenario where we have to balance the ball on the floor. Okay, and we're also going to take a look at how we can apply materials to actors in our level. Okay, so let's take a look at how we can add the ball to our level. We've yet to add any content to our level from the content browser, so let's take a look at doing that now. If we come back to the main content folder, inside the starter content we have this shapes folder, and we've got all these different shapes here, and look, one of them is a sphere, so it's pretty similar to a ball. Yeah, we could use this for our level. We can click and drag this into the viewport to add it to our level. Okay, and look, it's added this sphere to our level now. So this sphere is a static mesh actor, and it is named shape sphere. And we want this to be our ball for the game. We can rename this to ball. We can do it in the details panel, or by selecting the actor in the world outliner and then selecting it again to allow us to rename it. Okay, we can rename this to ball. And we can see that our ball has a basic white material on it, and when we have it selected, we can see the material in the details panel. And the starter content has a bunch of other materials that we can use to replace this material with. Okay, we can do this by clicking and dragging the material and dropping it onto the actor in the viewport, or by dragging and dropping it onto this material slot. So I now have a challenge for you. Using the starter content, I want you to replace the ball material, and then I want you to replace the floor material. Okay, so pause the video here and make sure you check out all the different materials that are included with the starter content. And then when you're ready, come back to the lesson. Okay, so in my level, I've used the concrete tiles for my floor piece, and I've used the metal gold for the ball. So let's take a look at what happens when we hit play. We've got this ball in the level, it's not moving or anything, and when we move our floor just goes through the ball. Okay, so we want the ball to react to the floor and also have its own presence and move around. So to do this, we want to apply physics to the ball, and we can do this by selecting it, and then on the details panel we can scroll down to the physics section, and look, we can check simulate physics. Let me just bring the ball up a bit in the air, and look, when we hit play, it drops down. Okay, and when we move our floor, it starts rolling. But look, it kind of freaks out immediately when we start moving around our floor piece. Okay, so we're going to take a look at fixing this and why it's doing this. So the reason this is happening is because the moment we rotate our floor actor, Unreal is giving us some default behavior with the physics. Okay, it's saying that the physics velocity of the floor is changing. It's updating and it's applying an upwards force to the ball. So our floor is basically launching the ball upwards into the air. So our solution to this is to ignore the force being applied to the ball, and we can do this by teleporting the physics state of the floor actor. So that sounds really crazy and complicated to do, okay, but it's really no problem because Blueprints allows us to do this very easily. So we can fix this by heading back into our level blueprint, and where we have our add actor world rotation function, there's more features to this function. We can find them by clicking this arrow here, and look, there's an input for teleport. So if we check this, this is how we teleport the physics state, and it tells us this in detail here. So let's just go ahead and do this for all the different rotation functions we've got in our blueprint. Okay, now let's come back to the level and hit play. And look, the ball drops down, and when we rotate the floor, it no longer freaks out and launches the ball. So now we're getting this gameplay where we have to balance the ball on our floor actor. This is pretty good progress, but it's a bit hard to control. We have to button mash the keys to rotate the floor, but we're going to fix this in the next lesson by taking a look at how we can control our floor actor with the mouse. So when you're ready, let's just jump straight into the next lesson. Hey, welcome back. This lesson is event tick and input axis events. In this lesson, we're going to learn how to control the floor actor with our mouse input. To do this, we need to use input axis events. We're also going to learn how we can read the input values from our mouse. And we're also going to be taking a look at the event tick. Okay, so let's take a look at how we can make use of our mouse input. Let's head into our level blueprint. And instead of closing and reopening our level blueprint all the time, which is pretty annoying, we can actually just take this tab and we can dock it next to our level tab here, so we can just switch between them. So where do we find our mouse events? Well, let's come to an empty space on our graph and let's right click and let's come to input again, because we're dealing with input, but we're looking for some mouse input. So look, we have mouse events. When we double click here, we can see we've got events for the left mouse button for when you actually click it, and the right mouse button. But look, we have mouse X and mouse Y. So mouse X will be when we pan our mouse left and right, and mouse Y will be when we pan our mouse up and down. Let's get both of these events. So we'll right click again and come to input, mouse events, and then mouse Y. I'm going to move my mouse Y just a bit further down just so we can focus in on this mouse X here. So this event looks different to the input action events that we've been using, and this is because this event is an input axis event. Look, if we hover over this event with our mouse, it says this event provides the current value of the mouse X axis once per frame when input is enabled for the containing actor. So what this is saying is, wherever this event is, if it can receive input, in our case it's in the level blueprint, and we can receive input because we've been using some input events already, it's telling us that this is going to update every frame and return the mouse X value. You might have heard of the terms frames per second or frame rate. This refers to how many images are being displayed on our screen per second, and we can view our frames per second by coming back to the level, and in the viewport we can click this arrow here and we can check show frames per second. Okay, so we can see that my frames per second are about 120 frames per second here, and so this means that the mouse X event is going to fire 120 times every second. And every time it fires, it's going to return the mouse X value in this axis value pin, which is a float. And a float, or a floating point, is a fractional value that has a decimal point and numerous values after it. So for example, this value could return 5.6789. Okay, and we can read the value and print it to our screen by using a print string again. We can right click and search for our print string, and look, when we click and drag this green float pin, we can plug it straight into the string input, and look, it says convert the float to a string, and it adds this node for the conversion, and we can hook up the execution pins together here. And then if we come back to our level and hit play, and if we click in the viewport and move our mouse, look, if we move it left it goes negative, and if we move it right, it goes positive. Okay, so negative values for moving left and positive values for moving right. And the faster we move our mouse, or the further we move it, it's going to give us some higher values or lower values if we're moving left. So our mouse X event fires every frame, which means if we're running at 120 frames per second, this means the event executes 120 times per second. And so we have this axis value, which gives us the input of our mouse X movement. And we can read this value by connecting the float value to the input of a print string. And this means when we play the game, we can read the values. So let's take a look at using this event to control the role of our floor actor. So to do this, I'm going to remove my print string and the conversion for the float to a string. And then I'm going to select the floor reference we've got here, and then shift select the add actor world rotation function. And if we hit Control W, we can duplicate this down and we can plug this to the execution pin of the mouse. Before plugging the axis value into this, look, we can see that we've still got the value of 5 on the roll. What happens if we hit play? Well, it's rolling it by 5 units every frame. Okay, but how can we plug this axis value into this? This pin here, we can hover over it. It says it's a rotator, which contains the roll, pitch, and yaw. And we can access the roll, pitch, and yaw individually by right-clicking on this pin and splitting this struct pin. Okay, now we have, look, the individual roll, pitch, and yaw, and their float values, which allows us to plug the axis value straight into the roll here. Now when we come back to our level and hit play, we can now roll our floor actor just by panning our mouse left and right. So I now have a challenge for you. Using what we've learned and using the mouse Y event, I want you to control the pitch of the floor actor. So pause the video here and give it a go, and when you're ready, come back to the lesson. Okay, so to control the pitch of the floor actor with our mouse Y event, we can duplicate this world rotation function, and we can hook up the mouse Y execution pin to this function, and we need to provide the target. So who is being rotated? Well, it's our floor reference, so we can use this here. And then we want to control the pitch, so we can plug the axis value straight into the pitch. And now when we come back to our level and hit play, we can roll and control the pitch with our mouse. But for me, the pitch is inverted. So how do we fix the inverted mouse situation here? Well, with our axis value, we can edit this before it goes into the pitch. Okay, we can just use some simple multiplication with this. If we drag this out and put in the star sign or asterisk, we can get a float multiplied by float. Okay, and if we multiply the value by -1, we will flip the value and invert it, and we can plug this result into the pitch. Okay, and now when we play the game, the floor actor pitches in the opposite direction and we can also roll. So this is looking good. But the more we pitch and roll the floor, you'll notice that the floor actor is offsetting on the yaw. It spins around a little. We will tackle that in the next lesson, but before we move on to the next lesson, I want to show you that there is a much easier way for us to rotate this actor with our mouse input. Let's come back to the level blueprint. I'm going to break the links on my mouse Y and mouse X events just to cut this off for now. And if you recall back when we first opened our level blueprint, we had an event begin play and an event tick that we removed. Let's bring the tick back. If we come below where we've just been adding our code, just to an empty space on the graph, if we right click and come to add event, we can get the event tick, and this is where we can also get the event begin play and a couple of others as well. But let's just bring the event tick back, and look, when we hover over this, it says this event is called every frame. Well, that sounds familiar because we are doing this on the mouse Y and mouse X events. So if we grab the floor reference and an add actor world rotation and duplicate it down with Control W, if we just hook this up to the tick and make sure we've got a value just in one of these, so I've got 5 in the roll. If I hit play, we can see that this is rolling every frame for 5 units every frame. Okay, so just like the behavior we had before. But how can we use the mouse X and mouse Y values with this? Well, we know we've got the axis values on these events. Okay, but if we right click anywhere, we can come to input again, and where we have mouse events, just underneath this we have mouse values. And look, if we double click here, we can get the mouse X and mouse Y values. So if we grab one of these, look, it's just giving us the float value. We don't need to call the event as well, because the event's doing the same thing as this tick here. It's calling every frame, and we have our mouse value. So really we're doing the same thing here, but only using one event. But we can also get the other mouse value, but before we do that, let's plug this into the world rotation. We need to split the struct, and then we can click and drag this into the roll. And now we can right click and come to input again, and then mouse values, and then mouse Y. and we can plug this in. But we also want to flip the value by using a float multiplied by float. We can use a star or asterisk to get this, and then set the value to -1 to flip it, and then we can plug this into the pitch. Okay, so look, we've done the exact same thing, but with only one event, so we've reduced our code. We no longer need our mouse X and Y events, so let's select all of these and remove them. And now when we play the game, we have the exact same setup as before, but with less code. Awesome! So we know that there's different ways to do the same thing inside of Blueprints. In the next lesson, we're going to code even further so we can fix this yaw offset issue we see when we rotate the floor. So I'll see you in the next lesson. Hello, welcome back to this lesson, which is getting and setting actor rotations. So we're going to be doing some more coding in Blueprints. We're going to take a look at how we can get the current rotation of our floor actor, and then using those values, we're going to set a new rotation that combines the input of our mouse. But this way will allow us to filter out the yaw rotation that will fix the yaw offset issue we see. And then we're going to wrap up this lesson by limiting the range of how far we can rotate the floor actor. Okay, so I'm currently playing the game, and I'm just going to roll the ball off our floor to begin with. So let's take a look at the floor. When we add pitch to the floor, and when we add roll, and then if we pitch the floor back and then roll it back, we can see that we've offset the whole floor actor on the yaw rotation. Okay, so when we combine the pitch and roll together, we have this annoying issue where we just keep rotating on the yaw. Okay, so this is going to be frustrating for the player. So let's take a look at fixing this problem. Let's come back into the level blueprint. We currently have it set up so that every frame we read our mouse X and Y values and add them to the rotation of our floor actor. And this add actor world rotation function, it's okay, it's been serving its purpose for us so far, but we need that little bit more control over our rotation values. So I'm just going to select this for now and remove it from the blueprint by hitting delete on my keyboard. And let's take a look at another way we can do this. If we drag out from the floor actor and come down to utilities and then transformation, look, this is where we got the add actor world rotation function here. So these are all add functions, but if we keep scrolling down, we come to some get functions, and look, we can get the actor rotation. And this has a rotator return value. If we right click on this, we can split it to gain access to the roll, pitch and yaw. We can also right click on the float pin to recombine the struct back into a rotator. And there's another way that we can gain access to the roll, pitch and yaw. If we drag out the rotator return value, we can see we have a break rotator that's suggested to us here. So we can select this and we can see we now have the roll, pitch and yaw. So we're really doing the same thing here. So like I said, there's multiple ways we can do the same thing in Blueprints, but we're going to work with this way for now. But this is okay, we can get the actor rotation values, that's great, but we can't set them with this function. So how do we do that? Well, we can drag out from the floor again, and we can scroll down to the utility section, and then transformation, and if we go past the add functions, and keep going past the get functions, we have some set functions, and look, we can set the actor rotation. Let's move this function over to the right, and we can see that this function is similar to the add actor world rotation. We definitely want to check the teleport physics because we want to teleport the physics state just like before. And we have the rotator pin on this function that allows us to set a new rotation. And we know that we can right click and split these rotator pins, but look, we can do something else here. We can click and drag out the rotator, and it suggests to us to make a rotator. And this gives us the ability to set the roll, pitch and yaw. So for setting a new rotation, we know that we can get the current actor's rotation, and we can break this out to give us the individual current rotations of the roll, pitch and yaw. We can set a new rotation for that actor using the set actor rotation, and we can individually set the roll, pitch and yaw. So you're probably thinking, well, how does this help us? Well, we can apply our mouse input using some simple math between these nodes. So let's take a look at this. I'm just going to select my set and make nodes, and I'm just going to move them across and just down a bit so we've got a bit of space between these two nodes. And look, we've got this big blue line going across here. Let's neaten this up. Let's break the link on this target, and let's get the floor and duplicate it with Control W and just plug this in here just so it's a bit easier to read. So we get our actor rotation and we have our mouse X value. So the mouse X controls the roll, and we know we want to apply the mouse X to the roll. So if we drag out the mouse X return value, we can search for the addition sign to get a float, add float. And we can connect the roll into the second input to this to add these two values together. And with this pin on the right, returning our new value, we can connect this into the roll on the make rotator. So we are now adding our mouse input to the roll rotation. So I have a challenge for you right now. I want you to take the mouse Y value and add it to the current pitch rotation of the floor actor. So pause the video here and give it a go, and then when you're ready, come back to the lesson and I will walk you through the process. So to do this, we want to take the current pitch rotation of our floor actor, and then with this we can drag it out and use a float, add float, just by searching for the addition sign here. Okay, and then with this we can use the mouse Y input to add these two values together. But remember, we invert the mouse Y value, so this is why we have this multiplication going on here. We can just plug this straight into here. I'm just going to move these across to get them closer, and then we can plug this into the pitch to make the new pitch. But look, we've also got the yaw here. Let's leave the yaw at 0 because this will constantly set the yaw to 0. And look at what happens when we connect this together and hit play. So we can pitch forwards as usual, and we can pitch back, and we can roll left and right. But look, the more we apply this together, we are not offsetting this on the yaw value. But we still have an issue here. We can just pan our mouse right and we can keep flipping this all the way around. So let's take a look at limiting the rotation of how far we can rotate this floor actor. We can see how weird it is when we do this. So we want to limit the range of how far we can rotate our floor actor. Let's say, for example, we want to limit the range to -40 and +40. So we have these range of values. Well, to do this, we can clamp our pitch and roll values, and Blueprints allows us to do this very easily. So let's take a look at how we can do this. If we come back into our level blueprint, where we do our addition with our mouse values, we can drag out the return value from the addition, and we can come to the math category, and under the float section, because we're dealing with float math here, we can find a bunch of different math functions, and one of them is clamp float. So we can call this function, and look, we have a min and max value, so we can set a range of our values here. So we can put -40 and +40, and we can connect the return value straight into the roll. And we can do the same with the pitch by duplicating this with Control W while it's selected, and we can plug our addition value into this and then plug the return value into the pitch. Okay, so now this is looking good. If we come back to our level and hit play, when we add pitch to the floor, it will limit the rotation if we go too far, and the same for coming back on the pitch, and the same with the roll. So we have a much better solution for controlling our floor actor by adding and clamping our rotation values. But we've been using this floor actor the whole time, and in the next lesson we're going to take a look at creating our own maze. So when you're ready, jump on into the next lesson. Hello and welcome to this lesson, which is BSP Geometry. In this lesson we're going to be taking a look at creating our maze, and we're going to be doing this by using BSP brushes. Using BSP brushes, we're also going to be taking a look at geometry editing and also how we can create an escape hole using geometry subtraction. Okay, so just looking at a very simple design, we're going to break down our maze by first adding a floor into our level, and then we're going to add some surrounding walls onto the floor. And then we're going to build the interior parts of the maze, which will just be some more walls that we add inside the surrounding walls. And then, of course, we want to add an escape hole that our ball can escape through. Okay, so to start creating our own maze, we're going to start by adding in the floor. But we've already got a floor here, but we don't want to use this floor. So what I'm going to do is select it, and then I'm going to hold left shift as well to select the ball, and we can just move both of these out of the way. So how do we add some geometry into our level that we can start using and editing? Well, we can come up to the Window tab, and we can come to the Modes panel. And on here, we can come to the Geometry section. So these aren't static mesh actors. These are BSP brushes. And we can use BSP brushes to start blocking out our levels. Okay, but in our case, we're going to be using these to create our maze. And we can see there's a few different shapes here that we can work with, but we're just going to focus on this box brush. And we can add the box brush to our level just by clicking and dragging it into the viewport. I've got grid snapping turned on, and my grid size is set to 100 Unreal units. I'm going to reset the location of this brush actor to the center of the world by changing the location transform to 0, 0, 0. Our snapping size is set to 100, so we can see that one of these squares on the grid is 100 Unreal units in size, or 1 meter in size. Looking at the box, we can see that it fits on the grid across these two large squares on the face, which means that it's 200 units in size. If we look towards the details panel, we have this brush settings section, and it is telling us that the shape of our box is 200 units across the X, Y, and Z. And we can start changing the shape of our box by typing in new values here. So look, we can type in 100 on the X and Y to change this box to be 100 units for its width and its length. But we're going to use this box for our floor piece, and I want the height of it to be pretty thin. So I'm going to change the Z here to be 30 centimeters or 30 Unreal units. Okay, so that's a good height for our floor. We know we can change the shape of a box brush by adjusting these values on the details panel, but what we don't want to do is scale it with the scale transform tool in the viewport, because when we do this, it stretches our materials, which will make our maze look a bit ugly. So I'm just going to hit Ctrl Z to undo this. So we want to make sure we use the brush settings on the details panel, and for my floor I'm going to change the X to be 1400 units and for the Y to be 2000 units. Okay, so this looks pretty good for my floor piece. Now let's take a look at adding in a wall piece. To do this, we can just drag out another box brush, but with this box I want it to be the size of this square in the bottom left corner of our floor. So we can do this by changing the Y to 100 Unreal units. But look, if we zoom down to it, we can see that it sits in between one of these grid squares rather than being perfectly in place on the grid. So we can see this better when we start moving it. If we bring it to the edge of our floor, we can see that half of it is hanging over the edge of the floor. So to fix this, we just need to change our snapping size to 50 units, and then we can move it across so it sits nicely on the grid in place there. But we want to change the length of our wall to be the same length as our floor piece. So how can we do that? Well, we can switch over to the geometry editing mode. To do this, we want to come to our modes panel, and where we have all these icons, there is the geometry editing icon on the very end. So when we select this, we are in the edits mode, and this allows us to select a face on our box brush, and we could just use the translate tool to change the length of our face. And we can do the same for a different face, so I'm going to do the same for this top face here to change the height. So to summarize, when editing BSP brush shapes, we can use the brush settings on the details panel, and we can also use the geometry editing mode from the modes panel. This allows us to select faces and use the translate tool to change the length of them. But we don't want to use the scale tool in the viewport because this causes stretching of the materials. So I've still got this face selected on my wall. I can deselect it by hitting escape, and we can deselect the actor again by hitting escape again. Let's take a look at applying materials onto these brushes. Well, if we come back to the content browser, we know in the starter content we have the materials folder. And we know if we drag and drop materials, usually it would apply it across the whole actor, but it's only applying it onto a single face. Okay, so we can technically drag and drop different materials onto different faces here. But what if we want to apply a material across the board, across all the different faces on our brush? Well, we can select the actor, and we can see on the details panel, we have this select button. We can select this and hit select all adjacent surfaces. And we have this surface materials section, and this says display free materials. If we hit this, it shows us all the materials we have on our brush, and we can just drag and drop a single material onto this to combine it all into one material there. Okay, so let's come back to the Place tab on the Modes panel, which is the first icon, and let's come to the Geometry section, and let's add another box while we've got the material selected. And because we've got the material selected, it's applied the material across all the faces on the brush. So let's take a look at finishing off the rest of the walls. Let's make this box go from this end of the floor to the opposite end. So to do this, on my brush settings, I'm going to change the X value to be 100 units, and take note that we're still on 50 units of snapping here. We can just use the translate tool and move this into place. We can switch to the geometry editing mode from the modes panel, and we can select the top face of the brush, and we can extend it to the same height of the other wall. If we select the side face, we can extend this face to the same length of the floor. Okay, and we can easily create the surrounding walls by coming back to the place mode, and if we select one of the walls, we can hold down the left Alt and just click and drag to duplicate it, and we can duplicate them into place quite easily. Okay, and we also want to apply the material to the floor, so we can select it and then select all adjacent surfaces and drag and drop our floor material on there. So now I have a challenge for you. Using what we've learned, I want you to create your maze. To do this, make sure that you've got a floor and some surrounding walls as we've just set up, but I also want you to set up your interior walls to create your maze, and your maze can be as big and as small as you like. But I also want you to apply materials to all the faces on the walls and the floors. So pause the video here, have fun making a maze, and hop on back and hit resume when you're ready. Okay, so this is my simple maze that I've created just by using a combination of the geometry editing tools and the brush settings when we are working with the box brush. So we can bring our ball back and we can just choose our starting point over here. And let's think about an end point for our maze. So somewhere where the ball can escape from. We want to cut a hole into the floor. So how do we do that? Well, if we come back into the place mode on the modes panel, and then geometry, look, we can hit additive or subtractive modes, okay? So we've been working in additive mode, but if we go into subtractive and drag out a box, it will cut out geometry for us. And we just want to make sure that the subtractive box is inside the geometry of our floor, and we can see that it cuts a hole there for us. And we can just use the regular brush settings just to make sure that we have a hole large enough that the ball can escape through. Okay, so in the next lesson, we're going to take a look at converting our maze into a single static mesh actor. So when you're happy with the design of your maze, let's hop on into the next lesson. Hey, welcome back. In the previous lesson, we made use of BSP brushes to start blocking out a maze. And BSP is good for designing and blocking out levels, but it's fairly limited. For example, BSP brushes cannot be used in blueprints, and we want to use our maze we have designed in our level blueprint. So in this lesson, we're going to cover how we can convert all our BSP geometry down to a single static mesh. And we're also going to be taking a look at different ways we can apply collision to a static mesh, and we're also going to replace the floor actor reference in our level blueprint with our newly created maze static mesh. Okay, so we want to take our BSP box brushes and we want to convert them to a single static mesh. To convert a BSP box brush to a static mesh, we can select it, and when we scroll down on the details panel to where we have our brush settings, we can expand this little white arrow just on the bottom of the section here. You can see this little white arrow. When we hover over it, it says show advanced. When we click here, we have some buttons, and look, we have a create static mesh button. We're not going to click it just yet. What we want to do is select the whole maze and then convert that to a static mesh. But in order for us to do that, look what happens to our pivot point. If I look at the world outliner and if I select all the box brushes, look at where our pivot point is. It's towards the final actor that we have selected. So if we were to rotate the maze as we were doing with the floor, it's going to rotate it around its axis just there, which isn't good for our maze. We want it to be on the center of the floor. Okay, so look, if we just select half of these, we can see that the pivot point goes here. If we select these, we can see the pivot point goes there. So we want to make sure we select the floor last. So probably the best way to do this is to select the floor. So we know which one the floor is. Let's just hit F2 when we have it selected in the world outliner. And let's just rename this to box brush floor. So we know the floor is the last one. So in the world outliner, we can select the top one, and then we can shift select all the way down to the bottom, and the floor is selected last. And now we can go ahead and create the static mesh on the details panel, because look, our pivot point is in the center, so this is perfect for us. Okay, so we can hit create static mesh, and it's going to ask us where we want to save it. Let's create a new folder in the content browser. If we right click on the big content folder, and we can hit new folder, and we can just name this mazes, and we can just name the static mesh name maze 1, and we can just hit create static mesh. Okay, and now we have our maze collapsed down to a single static mesh, and we can see that we have this little red message here saying that lighting needs to be rebuilt. This is because our maze is listed as static. If you remember, in a previous lesson we set our floor actor to be movable. So we want to do the same for the maze, and just like with the floor, we're going to be changing the transform of our maze dynamically with blueprints while playing the game. So we can come to the details panel and then change it in the transform section from static to movable. We can also find our maze in the content browser. We added it to a new folder named mazes, and when we come here we can see that we have a single static mesh just named maze 1, and we can double click on the static mesh to open it inside the static mesh window. And this just gives us a complete overview of our static mesh, and we can also apply collision here, but we're going to be taking a look at this shortly. Let's come back to the editor because I now have a challenge for you. Okay, so right now I want you to take your box brushes that make up your maze, and I want you to convert it into a static mesh actor. And remember, you need to select the floor last for the centered pivot point. So pause the video here, and when you have your static mesh actor ready, let's continue the lesson. So I'm assuming you have your maze converted down to a static mesh actor now. And now I want you to make sure you have your maze selected in the viewport, and with it selected in the viewport, let's come to the level blueprint. So our mouse input is controlling the floor actor, but we want to update our code so we can control the maze actor with our mouse input. So to do this, we can just replace the floor references with our maze reference. So because we have our maze selected in the viewport, we can right click and we can create a reference to our maze, and we can just plug this straight into the target and replace the reference here, and we can just delete the floor reference. Okay, we can do the same over where we set the actor rotation. We can create the reference and then just plug it in and then delete the floor reference. Okay, and now we can come back to the editor, and we want to make sure that we adjust our player start just so we can get a good view of the maze for the player when we are playing the game. So just using the translate and rotate tools, I can set this in place here. And when we're ready, we can hit play and just check out the view. And we can also see that we've got control of our floor actor here. And I'm just going to adjust my player start just a bit closer and more to the center of the maze here. So when we press play, we can see that the ball falls straight through our maze. Our maze has no collision, so we need to fix this. Let's come into the maze 1 static mesh by double clicking on it inside the content browser. So we have no collision at all on our static mesh, and with static meshes we can apply collision by coming up to the collision menu just next to file and edit, and when we click this we can apply different types of collision. Let's just take a look at what happens when we add a box simplified collision. So this adds a box collision primitive that covers our whole mesh, and look, we can use the translate tool to move this so we can see it better. And we can see that this is one whole solid piece of collision, but this is no good for us really because we have a much more complex shape than just a simple box. So what else can we do? Well, there's two solutions to this. Solution 1 is to scale the collision primitive and make it fit the size of the wall, and then we can keep adding more box collisions by alt dragging and duplicating the collision. But this is going to take some time and it's going to be iffy and difficult to do. So let's take a look at solution 2. Solution 2 is really not the best option in terms of developing a larger game, but for our marble run game and our maze static mesh actor, this is going to be just fine. I'm going to select and delete both box collision primitives, and we can apply collision to each face of our model by scrolling down on the details panel, and we can come to the collision section. And here we have collision complexity, and we can use this drop down just next to it, and we can apply collision to each face of our model by selecting use complex collision as simple. There is a solution 3, but that would require us to use a 3D modeling application such as Blender, and we're not going to dive into that in this course. So for this lesson, solution 2 is going to work just fine for us. So let's close out of the static mesh window and let's switch back to the editor and let's just hit play. So we can now see that the ball collides with our maze, and we can rotate the maze with our mouse, and we can start guiding the ball to the hole we cut in the floor to make it escape the maze. So in the next lesson, we're going to take a look at triggering an event in Blueprints for when our ball escapes the hole to give us a sort of win condition. So when you're ready, I'll see you in the next lesson. Hello and welcome back to this lesson, which is trigger volumes and overlap events. In this lesson we are going to be working with box triggers. We're going to learn how we can use overlap events inside of Blueprints, and we're also going to take a look at how we can parent our trigger box to our maze. And then we're going to wrap up this video by seeing how we can mark actors to generate overlap events. So let's take a look at how we could generate an event in Blueprints for when our ball escapes the exit hole of our maze. And we'll be able to use this event as a simple win condition for our level. So how can we get started with this? Well, we can come over to the modes panel, and on the modes panel where we have the basic section, we can scroll all the way down here and we can find a box trigger. And when we hover over this, it says a box shaped trigger used to generate overlap events in the level. So this is perfect. This is just what we need. We can click and drag this into our level. Let me just move it up so we can take a quick look at this. So we've just got a simple outline of a box, and on the details panel, we can see the units that make up the shape of the box. And just like the BSP brush, we can click and drag this to resize it. But we can also use the scale tool in the viewport to reshape this, and it's going to update these values at the same time. Okay, so there's two different ways that we can shape this trigger box. Now let's just go to the translate tool and let's move this over to near where our exit hole is, and let's take a look at how we want to shape this and place it. So if we were to place and shape the trigger box where it sits inside the escape hole and where its bounds extend above it, then we have a problem for when the ball tries to escape, because the ball might be moving fast enough that it has a chance to jump over the corners and other areas of the escape hole, causing it to travel in and out of our trigger box. So this is going to cause our overlap events to fire while the ball is still inside the maze. So this isn't really going to work for us because we want the events to fire when we know the ball has escaped the maze, so we need a better placement for this. And the solution for this is simply to place and shape the trigger box underneath the escape hole of the maze. So a challenge for you right now is to add a trigger box to your level, and I want you to place and reshape it underneath your maze escape hole. So pause the video here, have a go at placing and shaping your trigger box, and then come back to the lesson. Okay, so here is my trigger box placed and shaped underneath the escape hole of my maze. So this is looking good, and by default when we play the game we can't see the trigger box, and this is because trigger boxes are hidden in the game by default. Okay, so if we hit stop and if we select the trigger box, we can override it from being hidden by scrolling down on the details panel to where we have the rendering section, and look, we have a checkbox telling us that the actor is hidden in the game. If we uncheck this and hit play, we can now see our trigger box. Okay, but remember, we are dynamically changing the transform of our maze during gameplay, but we are not updating the position of the trigger box. Okay, so how can we fix this? Well, it's really easy to do. We can select the trigger box and we can attach it to the maze by coming to the world outliner, and we can drag and drop the trigger box onto our maze static mesh. And we can see here it says attach trigger box to maze 1. So when we do this, the trigger box becomes a child of the maze. The maze is the parent to the trigger box now. So if we hit play and if we move our maze, we can see that the trigger box is moving with the maze. Okay, so now we're ready to add some code with this trigger box. So let's head over to our level blueprint. And if we right click in the graph, oh, it's telling me to select actors to see available events and functions. So basically this means I haven't got an actor selected in my viewport. So we want to make sure we've got the trigger box selected. And now in the level blueprint, when we right click, we can see that we can create a reference to the trigger box, and just above we can call functions and also add events. And we want an event for our trigger box. So let's double click here and look, we have different types of events, but we want a collision event. So let's double click on collision. And look, we have begin overlap and end overlap events. So begin overlap is when an actor enters the trigger box, and end overlap is when an actor exits the trigger box. Well, we want an event for when our ball escapes the maze, so the end overlap is the event we want to use here. So looking at this event, we have our friendly execution pin, and we also have this overlapped actor return value. This is returning a reference to who was overlapped, and in this case, it would return a reference to our trigger box. And we also have this other actor return value. This is returning a reference to the actor who made the overlap. In our case, it would be the ball. So we now have our overlap event, and we need to make sure this event is properly firing when our ball escapes the maze. So an easy way to do this is just to drag out our execution pin, and we can just use a print string, and let's just print a simple message to the screen, something like ball has escaped. Okay, now let's come back to the editor where we have our level. Let's just see what happens when we hit play. So if I just play through my level, we can see that when we get to the end of the level, when our ball escapes, we don't get a print string. So our overlap event didn't execute, and there's a final step to all of this. We need to make our ball generate overlap events. We can do this just by selecting it, and on the details panel, we can scroll down to the collision section. Let's just expand this little area here, and look, we have this generate overlap events, and it's unchecked, so this is why our event didn't fire. So if we check it and play the game again, let's just see what happens. When we get to the end of the level, we now see our print string. So when working with triggers and overlap events, we need to make sure we mark actors to generate overlap events. Okay, so in the next lesson, we're going to take a look at how we can time how long it takes us to escape our maze. So when you're ready, I'll see you in the next lesson. Hey, welcome back to this lesson, which is returning game time in seconds. In this lesson, we're going to learn how we can find out how long it takes for the player to escape the maze. We are then going to print a winning message to the screen. And with this message, we are going to combine a message and the time it took to escape the maze. Then we're going to wrap up this lesson by making use of the delay function and restarting the level after we have completed it. So let's take a look at how we can time how long it takes for our ball to escape the maze. So we have this end overlap event here that fires when our ball escapes, and we print a simple message to the screen with this print string. Let me just select both of these nodes and let's just move them down a bit. Okay, so how can we get our print string to display the time it takes for the player to make the ball escape? Well, we can use some time functions to achieve this. If we right click and scroll down to the utility section, when we double click here, we can find a time category. If we double click here, we can see a bunch of different functions that are linked to time. And one of these is a function named get game time in seconds. Okay, so this sounds good for us. Let's grab this. So this returns a float value, and it's going to be in seconds, and it tells us how much time has passed since we've hit play. So if we were to connect this to the print string, we can see that it does a float to string conversion for us. Okay, so when our ball now escapes and executes the end overlap on our trigger box, it should print the amount of time it took for the ball to escape. So let's come back to the level and try this out. Before we hit play, remember you can always move the ball to the end of your maze for testing, so you don't have to play through the whole of your game to see this end result. But I have the ability to fast forward the video here, so I'm just going to leave the ball where it is and I'm going to play and fast forward. So our ball escapes from the maze and it prints how long it's taken. Great, but we can see that the value here is pretty long. It has a fractional value of 6 digits. We can see it is 0.502593. So this is very precise. We can probably just cut this down to about 2 fractional values. So let's head back to the level blueprint and let's see how we can do this. So there's different ways we could approach this, but I'm just going to show you one easy solution that we could use here. Let's remove our float to string conversion, and if we drag out and release our float return value, we can come down to utilities and then the text category, and let's convert this from a float to text by calling the toText function. Let's just move our print string along further, and then with the return value of the toText, we can plug this straight into the string input on the print string. Okay, so why am I doing this? We are converting a float to text and then to a string. That doesn't really seem like it would help. But look, on the toText conversion function, we can hit this little white arrow and expand it, and there's a bunch of inputs here we can use. If we look at the input at the bottom, we have a maximum fractional value we can adjust. Let's just go ahead and change this value to 2. We don't even need to do anything else. We can just collapse the function and make it smaller by hitting the white arrow again. And now let's come back to our level and hit play. I'm just going to fast forward through the gameplay again. And now when we reach the end, the seconds are displayed, but they are now cut down to 2 fractional values. Okay, great. So let's come back to the level blueprint and let's take a look at how we can build a winning message. So for building a winning message, let's look at an example. Let's imagine that it will take us 22.53 seconds to complete our maze. So we would want a winning message to say something like, "Well done, you escaped the maze in 22.53 seconds. Well, we would have to chop up our message into sections. The first section would be, "Well done, you escaped the maze in." And then for the second section, we would have to plug in the game time in seconds result. And we would have to finish off the message with a final section. So this is actually pretty easy to do in Blueprints, and the solution for us is to use the append string function. So to use the append string function, I'm going to break the link on the input for the string. I'm just going to select and move my get game time in seconds functions just out of the way, so we've got some more space in between the print string. And now let's drag out from the input of the print string, and let's come down to utilities, and then string, and look, the first function here is append. And the append function gives us an A input for the string and also a B input for the string. So we can combine 2 messages now. But look, we can also add string inputs by using this add pin, and there's no limit on how many of these we can add. So in the A input, we can type in, "Well done, you escaped the maze in," and then we can hit spacebar to add a space there, and then we can plug our get game time in seconds result into the B input, and then we could use another space on the C input, and we can type in seconds with an exclamation mark. So let's come back to the level and let's hit play and see what happens. When we get to the end and when the ball escapes, we can now see we have the full message printed on our screen. Okay, so it works. We can set up a custom message by combining values and strings together in Blueprints. Okay, so right now your challenge is to build your own winning message the player will receive when they make the ball escape. Be creative and combine the time it took for the ball to escape the maze by appending the game time in seconds into the string. Remember to change the length of time that the string is on the screen for. And remember to change the color of the string. So pause the video here, have fun creating your message, and when you're done, come back to the lesson and hit resume. Okay, so I've already built my winning message, and I hope you've had a go and created your own fun winning message as well. And remember, we can change the properties of the string that gets printed onto our screen by expanding the white arrow on the print string function, and here we can change the text color and the duration that the string is on the screen for. So while we're here, let's do one final thing to wrap up this lesson. Let's make it so when we receive our winning message, we delay the game by 5 seconds and we can restart the level to try and beat our score. So to do this, we can drag out the output pin of the print string. We can type and search for our delay function. We want to delay it by 5 seconds, so we can change the duration to 5. And then from the completed output, we can drag out this pin and we want to restart the level. Okay, so to restart the level, we can come down to the game category. And when we expand this, there's a bunch of game specific functions. And look, there's a function named open level. Okay, and it just asks for the level name. Well, we can see the level name up in the top left of the editor. We can see that we are in level 1, and remember we can see the level in the bottom right corner of the viewport. So the level name is just level 1 for me. So let's just zoom out here. So when we receive our overlap event from the trigger box, we print the winning message and we delay by 5 seconds, and then we restart the level. So let's compile, let's hit save to save the level, and let's jump in the game and hit play. So we can use our mouse input to rotate the maze, and this causes the ball to move around because it's simulating physics. And because of this, we can try to guide it to the end of the maze and let it escape. And once it escapes, we receive a winning message that tells us how long it took for the ball to escape the maze. Then after 5 seconds, the level will restart so we can try and beat our previous time. Okay, great, so this is really good progress and our game is pretty much there. In the next lesson, we're going to take a look at fixing a few issues that might pop up when we play the game. So when you're ready, let's just jump straight into the next lesson. Hey, welcome to this lesson, which is bug fixing and blueprint code cleanup. In this lesson, we are going to remove any unused code for our game, and we are going to organize our code by using comment sections. And then we are going to solve a couple of bugs that I have found while developing this game. So let's start this lesson by removing any unnecessary code we have created so far. I'm going to come over to my level blueprint. And let's just take a look at all the code we have created so far. So we have our begin overlap event for the trigger box, which triggers the win message for when our ball escapes out the maze. So we want everything we've added here. If we move further up, we have the event tick, updating the rotation of the static mesh maze with our mouse input. So this is good, we certainly want this. And further up, we have some input action events for rotating the floor actor. Well, we are using the mouse for our input now, and we are not even using the floor actor. So we can remove all of these nodes here. And let's actually come back into our level and delete the floor actor if you haven't done so already. Let's come back to our level blueprint. And let's move up to where we have our begin play node. We have a few delays and print strings here from an earlier lesson. If you want, you can use a print string here on the begin play for a welcome message to the game. So we would just need a single print string for this. We can get rid of all the other nodes and we can just hook this up just to the begin play here. And a simple welcome message could be something like, welcome to my maze, how fast can you escape? And we can change the color if we want and change the duration here. I'm going to change mine to 2 seconds. And we can test this out by coming back to the level and hitting play. And now we have a simple message that pops up when we play the game. But it's a bit quick, so I'm going to come back to my level blueprint. And I'm just going to change the duration of my welcome message from 2 to 4 seconds. Okay, so what else can we do here? Well, we can organize our code further by selecting nodes. And when we have nodes selected, we can press the C key to add a comment section. So we can comment these nodes as a welcome message. We can come down to the events tick where we rotate the maze floor actor with our mouse input, and we can comment these as maze mouse input, and we can comment our box trigger code as win level event. With comment sections selected, we can see on the details panel that we can change the comment's color and font size, and we can also select and move every single node in the comment section just by clicking and dragging and moving the comment section. We can select multiple comment sections and we can click and drag them to move them up, and now we have all our code organized nicely into one place. So your challenge right now is to organize your code into comment sections and have a go at changing the color of the comment sections as well. So pause the video here and give that a go, and when you're ready, come back to the lesson. Okay, so I've colored my welcome message comment section as blue, my event tick as red, and my win level event as green. So this is great. This is a lot more organized for us. Let's head over back to our level, and let's take a look at some potential bugs that might happen when we play the game. I'm just going to hit play, and I'm going to fast forward to the end of my maze. We can see that if we move the maze around while the ball is escaping, we get more than one win message. So let's break this down. When the ball exits the trigger box, we get our first win message. So this is fine, this is what we want. However, if we move the maze, the ball can end up back inside the trigger box and then fall out of it again, causing additional messages. So really our solution to this is to make sure that we only fire this event once. And Blueprints allows us to do this very easily. Let's come back to our level blueprint. And let's look towards where we have our win level event, which is really just the end overlap event of the trigger box. So we only want this event to fire once. So how can we do this? Well, we can use a flow control node. If we drag out from the execution pin of the end overlap and then come down to utilities and then the flow control category, we can find a bunch of nodes here that affect how we execute our code. And look, we have a do once. When we hover over this, it says output fires only on the first time this node is hit. So this is great. We can use this in our code, and we can see when we add it, it adds it nicely into our comment section here. Let's come back into our level, and let's test this out just by hitting play. So now we only get the single win message. So the do once node has helped us here. This is what we can use to limit our blueprint code to only fire once. So let's take a look at another bug with our game. When we hit play and rotate the maze really quickly, we can see that the collision of the ball gives up and it just falls through the maze. So let's take a look at what's happening here and what we can do to fix it. So this issue is a result of us adding rotation. Looking at the mouse X inputs, if we don't move the mouse, we have an input value of 0, and this results in no change for the roll rotation for the maze. If we move the mouse, we might end up with an input of 0.8 for the mouse X, and this means that we will be teleporting and rotating the roll of the maze by 0.8 units every frame. And this is okay because it's gradually increasing its rotation every frame, and the ball can catch up, it has a chance to update its location and still collide. So really, we are teleporting the maze to a new rotation every frame, and there's an issue here. If the roll is at 0 and then suddenly teleports to a new rotation that is vastly different than before, the ball can end up inside or below the mesh, and this is what causes the ball to fall through. So we need to limit how much rotation we can apply at once to avoid this issue. We can also mark the ball to be more accurate with its collision detection. This is a setting known as continuous collision detection, and this actually helps, but it's not a complete solution. It's turned off by default, but it's okay for us to use because we only have one physics actor in our game, so it's not going to be heavy or cause a problem if we use it. But the real solution here is to clamp the mouse input values. So this is how we can avoid the ball falling through the maze. So let's take a look at enabling continuous collision detection for the ball. This could potentially cause performance issues if we enable this on hundreds of physics actors, but we just have the one, so it's perfectly okay for us to use. So to do this, we can just select the ball, and on the details panel we can scroll all the way down till we find the collision section. and we can expand this little white arrow that says show advanced when we hover over this, and we can find some more settings here. And look, it says use CCD, which is continuous collision detection, and we can just go ahead and check this. And now we also want to take a look at clamping our mouse input values. So to do this, we want to head back to our level blueprint. And where we have our maze mouse inputs code, let's find our mouse X return value. With this, we can clamp it by simply dragging it out and releasing the float return value. And we can type and search for clamp. And we want to use the clamp float here. And now with the clamp return value, we want to make sure that it gets added to the current role of the maze. And now all that's left is just to set how much we want to clamp the mouse input to, and this might vary for different mazes. But for me, clamping the mouse between -1 and +1 works well. But just remember, you can change this to suit your maze. And now we want to repeat this for the pitch controls of the maze. So with the mouse Y and also with the multiply, where we invert the value, we can drag out the return value here and search for the clamp function again. We just want to make sure that we add this to the current pitch of the maze, and that we clamp this between, well, for me it's going to be -1 and +1. Okay, so this looks good. We now have it set up so our mouse input values are clamped. So let's come back to our level and let's just hit play to test this out. Okay, so this looks good. I no longer have the issue where the ball is falling through the bottom of the maze. So, as with any game during development, unexpected issues might pop up and you might find some yourself. So we might want to provide a way that a player can restart the level if they want to. So now I have a real challenge to test your blueprint skills. I want you to add an input action event, also known as a key event, and I want you to use this event to restart the level. And then make sure that you add a comment section for this blueprint code. So pause here and attempt to have a go at this, and then when you're ready, resume the lesson and I will walk you through the process. Okay, so to do this, I'm going to come next to my welcome message section. I'm going to right click and then come down to the inputs category. And I'm going to look for a keyboard event. And we're going to use, let's say, the R key here. And we can use this input action event to restart the level. Well, how do we restart the level? Well, we just need to call the open level function. So we can drag out from pressed and we can type in open level and we can just restart the level by providing the level name here, which is level 1 for me. And then we can select all of this code, we can hit C to add a comment section, and then we can name this restart level. And then I'm going to hit compile and save, and now we can come back to our level and we can hit play. When we press R, we now have a way that the player can restart the level if they wish to. Great, so you might find more issues in your game, and if you do, don't worry, feel free to share them in our community so we can take a look, and you might even get some help from some students that have similar issues. For the next lesson, we're going to take a look at packaging our game so we can play it in a standalone mode without the Unreal Editor. So when you're ready, I'll see you in the next lesson. Hello and well done for making it this far. This lesson is packaging your game. In this lesson, we're going to take a look at how we can run the game without the Unreal Engine 4 editor present. We're going to take a look at how we can set the default levels that open when we launch the editor or when we launch our packaged game. We're going to learn how we can reduce the size of the game by only packaging the content we are using, and we will take a look at the difference between development and production builds. Okay, so I'm assuming you're happy with your maze now, and remember our maze is converted down to a single static mesh, so if you want to make any changes to the design of your maze, you'll have to start over with the BSP Geometry. But we can still change materials without having to do this because we made sure at the BSP level that we had applied different materials to the walls and to the floor. So you can use the starter content materials just by dragging and dropping them onto your walls and floor to make sure you're happy with the final look of your maze. So we have our playable game in the editor, but now we want to run it like a regular game without the editor. So in order for us to do this, we need to package our game. But there's a few things we want to take a look at before we go through the packaging process. So to do this, we want to come to the project settings, and we can find this by coming up to edit and then project settings. So this has brought us to the description section of the project settings, and there's some basic things we can do here, just like changing the default icon for our project that we see in the Epic Games launcher, and we can also change the default name from UE4 game to something else. For me, it's just going to be Marble Run. And there's other details you can fill out here about your project and yourself, but for now let's move on by coming to the Maps and Mode section of the project settings. So what can we do here? Well, here we can set the default maps for the project. We can set the editor startup map and also the game default map. And we can see the maps assigned to them both here. And if you remember back when we first opened our project, it opened the minimal default map, and this is why it opened it, because it's set to open it by default here. And we can change the level that is opened by default for the editor by dropping down and selecting our chosen map here. So we can just select level 1. But we can also set a different map that opens by default when we launch our packaged game. So we don't want our players to be in the minimal default level. So I'm just going to go ahead and change this to my level, which is level 1. Okay, so this is looking good. We know that when we launch our game, we will be in the correct level. So now let's move on to the packaging section. So we only have one goal here. By default, if we were to package our game, it would package every level that exists in our project and every piece of content that is used in those levels. But really, we only want to use one level, and we are only using 2 static mesh actors and a couple of materials in our level. So we only want to package what we use, which will limit the amount of unnecessary content being packaged. So underneath where we have the packaging section, we're not going to worry about all these options here. Instead, we want to show some more advanced options, and we can do this by clicking on this little white arrow, which allows us to see some more advanced settings. So we are looking for the checkbox that is named Cook Only Maps. So this is what we need to use in order for us to only package particular levels. We can go ahead and check this, but we now need to go down and look towards where we have list of maps to include in a packaged build. So we can add levels that we want packaged by hitting the plus icon, and then we have to browse to where our level exists by hitting this browse icon. It will browse to the content directory of our project, so we can just come to the folder where we stored our level, which is maps for me, and then the map file, which is level 1 for me. Okay, so this is good. We are now ready to package our project. So we can close the project settings. And now we can take a look at how we can package the game. To do this, we want to come up to File, and if we look down, we have the Project section, and here we can package the project. There's different platforms we can package for, but we have designed this game for desktop, and I'm using Windows, so I can only package for Windows, and because of this, I am unable to package for Mac. I would have to open my project on a Mac in order to package for it. So for Windows, I can package for 32-bit or 64-bit machines, but I'm not going to package just yet because there's something else we need to be aware of. If we look further down, we can choose a build configuration. We have a choice of development or shipping. So this is actually going to affect our game. Let's back up a step. What do I mean by this? Well, let's come to our level blueprint and take a look. Looking at a print string function, we can see that it's marked for development only. So when we hover over it, it says this node will only be executed in the editor and in development builds in a packaged game. It will be disabled in a shipping build. So if we were to package a shipping build, it's not going to print our string messages to the screen. So we want to make sure that we use the development configuration. Another difference between development and shipping configuration is that the shipping has the console command disabled, which we haven't yet taken a look at, but I just wanted to point that out for you. So let's actually go ahead and package our game now. We want to make sure we are using the development configuration, and we can proceed with packaging for the platform we are running. So I'm running on a Windows 64-bit machine, so I can select this here. It now asks us to browse on our machine to where we want our game to be packaged to. I have got a Marble Run folder on my machine, so I can choose this here, and as soon as we hit select folder, it's going to start the packaging process. It doesn't take too long to package the project, but I'm just going to fast forward for now. So now my game is packaged. If we browse to where we packaged the game on our machine, we will find a folder named Windows No Editor. So it's packaged it for Windows with no editor needed to run it. We can rename this folder just by selecting it and hitting F2, and I'm just going to name mine Marble Run. when we come inside this folder, it shows us some content files and folders, but the main important one here is that we have a marble-run.exe. When we double click this, we launch our game, and we are now playing the game without the dependency on the Unreal Engine 4 editor, so this is completely independent now. So we can make our ball escape, and when we do, we get our win message, and then after 5 seconds, the level restarts. And we can manually restart the level by pressing the R key. But what happens if we want to quit the game? If we hit escape, it's not closing the game for us. That's because that's a control of the editor and not the game itself. We have to set this up manually, so I'm going to have to hit Alt F4 to close out of my game. So let's fix this up so we can press escape to quit the game. Let's come back to Unreal and let's open up the level blueprint. And in here we want to add some code that will allow us to quit the game by hitting escape. So your challenge right now is to add an escape input action event to the level blueprint, and then try and find and use the quit game function. And then with this, add a comment section. So pause the video here and have a good go at it, then resume the lesson and I will walk you through the process. So to do this, we can right click in the graph and we can come down to where we have input and we look for the keyboard events, and here we can find the escape key. So we have our escape input action event, but how can we call the quit game function? Well, we can either come to the game category or we can just simply type and search for quit game and we can get the function this way. Okay, and finally we just want to add a comment section for this line of code. So let's just hit compile and save to save the level, and let's close the level blueprint. And now we are ready to package the game again, but we need to delete the previous packaged build. So we can come back to the folder and just delete the whole Marble Run folder we have here. Okay, so once this is done, we can come back to the editor and then File and then Package Project and then Windows 64-bit it will be for me. And then we can just hit Select Folder and it will start packaging again. So I'm just going to fast forward through this process again. And now with the package complete, we can come back to the folder where we packaged the game. We can rename it from Windows No Editor to a custom name for our game. And we can open the folder to find our exe, and we can use this to launch our game. Okay, so we can play, we can press R to restart, but now we can hit escape to quit the game. Okay, awesome. So now you know how we can take an Unreal Engine 4 project and compile it down to an independent, playable, packaged build.